Hey class, factoring day 1. I'm going to record this video twice. I'm going to do once using the box method and once just using a guess and check method. I'm going to do the guess and check video first. This works really well for students who have really good number sense and are good at thinking of things like factors and multiples quickly. So it might not be the method for you. I'll show you what the box method is. First, the box method is like when you're multiplying x plus 3 times x plus 5, you make a 2 by 2 box. X plus 3 and then x plus 5. Then you multiply corresponding spots. So x times x is x squared, x times 3 is 3x, x times 5 is 5x, and 3 times 5 is 15. And then you combine like terms, so we have 1x squared, a 3x and a 5x is 8x, and then you have a 15 at the end. So that's how you multiply. So to factor with the box method, you work backwards. So you make the box, and you know that the first term goes in the first box, and the last term goes in the last box. So you put the x squared in the 15. And then you think, okay, what multiplies to 15 but adds up to 8? That's 3 times 5. 3 times 5 is 15. 3 plus 5 is 8, because remember along the diagonals these added to 8, but on the outside they multiplied to 15. So then you take those and you put those in the inside, 3x and 5x. It doesn't matter where you put them, and then you figure out the outside of the box. So the only way to make x squared is x times x, and then x times 3 is 3x, and x times 5 is 5x, so it factors to x plus 3 and x plus 5. So if you think that would be a good method for you to try, I would stop and watch the other video, because I'll do all of the problems with the box method in the other video. This one I'm going to do more of guessing and checking. So for factoring, there are some patterns that are good to remember. The first one here is if you have an x squared plus and plus, then your factors will factor to x plus something and x plus something. If you have a negative at the end but they add up to a positive in the middle, you're going to have one factor that's positive and one factor that's negative, and the positive one will be larger because when you add them together, the middle term is going to be positive. If you have a negative at the end but a negative in the middle, then you're going to have, again, you're going to have one positive factor and one negative factor, but this time the negative factor will be the larger of the two. And then if you have a positive at the end but it adds up to a negative in the middle, then both your factors have to be negative, because two negatives multiplied equals the positive at the end, but when you add them together you get the negative in the middle. So let me show you what I mean by that. So here I have a negative and a negative. So this is this pattern right here. So x squared is going to be x times x. And then what multiplies to negative 20 but adds up to negative 8? And that's going to be 10 and 2, and you have to have negative 10 and positive 2. So x plus 2 and x minus 10. So the negative one is larger because the 8 is negative. You can always check your answer by multiplying it back out. X squared minus 10x plus 2x minus 20. Okay, this one has a positive and it adds up to a negative. So this is going to be this pattern right here. You're going to have both your factors have to be negative for them to add up to negative in the middle, but multiply to positive at the end. So to get x squared, I know it's going to be x times x. And then I know they're going to both be negative. So then what multiplies to 50 but adds up to 15? So multiplies to 50 but adds up to 15 would be 5 times 10. So x minus 5, x minus 10. Those can be interchangeable. It could be x minus 10 times x minus 5. Negative on the end but positive in the middle means that the positive factor will be larger, but you have one of each because it multiplies to negative at the end. So multiplies to negative 16 but adds up to positive 6. Let's see, that would be positive 8 and negative 2. So it would be x plus 8 and x minus 2. And the last one, positive and positive. So they're going to both be positive right here. Multiplies to 6, adds up to 5. That'd be 2 times 3. So x plus 2 and x plus 3. Remember, you can always multiply those back out using the distributive or FOIL method to check your answer. So it is easier when our leading coefficient is equal to 1 because we know that our factors are going to follow those patterns. So if you just have an x squared, you know it's going to be x times x. Since this one is positive on the end and adds up to a negative in the middle, I know that both my factors will be negative. So what multiplies to 9 but adds up to negative 10? That'd be negative 1 times negative 9. So it's x minus 9 and x minus 1, or the other way around. Here, positive adds up to positive, so multiplies to 8 and adds up to 6 would be 2 times 4. Since it's just x squared, it's x times x, and it's going to be plus 2 and plus 4. So factoring is much simpler when the leading coefficient is 1, which means you just have an x squared. It does get a little bit more complicated when x is not equal, or a is not equal to 1, like these examples here. So first, it multiplies to a negative and adds up to a negative. So you're going to have one factor is going to be positive and one's going to be negative, and you kind of have to figure it out. So you can start, you know that it's 2x squared. There's only one way to make a 2x squared. It has to be an x times a 2x, or a 1x, 2x times a 1x. That's the only way to get x squared. So then you need to figure out how to get the middle numbers. There's two different ways to get negative 6. To get 6, it's either 1 times 6 or 2 times 3. Now the 1 could be negative, or the 6 could be negative, the 2 could be negative, or the 3 could be negative. This is where guess and check comes in. I need to make negative 11 in the middle. So whatever I choose here times the 2 plus whatever you take for the x times this number needs to make negative 11. So just guess and check. If I put the 6 here, that's going to give me 12x. And if I put the 1 here, then that would give me a 1x. I can make 11 out of that if the 6 is negative and the 1 is positive, because negative 6 times 2 would be negative 12, and x times 1 would be positive x, and together those add up to negative 11x. And then at the end, negative 6 times 1 is negative 6. So that would be my answer then. If I just clear this up by getting rid of this extra stuff, your answer would be x minus 6 times 2x plus 1. Let's try another one. So 2x squared again, so I know it has to be 2x times x, or x times 2x to get my 2x squared. Then I have 6 at the end, so I have to use these combinations, but this time I want to make 7. So I know that if I put the 6 with the 2, that would give me 12, and that's going to be too much. So I don't want the 6 there. What if I put the 1 here and the 6 here? Then I have 6 times x is 6x, and 2x times 1 is 2x. So that actually gives me 8. So I can't do those either. So I'm going to take those out again. So it means I have to use the 2 and the 3. So I'm going to have to put the 2 with the 2 to make 4x, and then the 1 with the 3 to make 3x, and then 3x plus 4x. 3x plus 4x is going to give me the 7x. It's positive on the end and positive in the middle, so both of these are positive. So then this would be my answer. You can multiply it all the way out to check. 2x times x would be 2x squared. 2x times 2 is 4x. 3 times x is 3x. 3 times 2 is 6. So 2x squared plus 7x plus 6. If you're very confused right now, it this method is very tricky. So I would recommend watching the box method instead. That one, there's a specific pattern, there's rules to follow. It's much easier in my opinion. I like that one better, but I wanted to give the opportunity for you to try both. Okay, so I'll do this one now. 3 is prime again, so there's only one choice to get 3x squared. It's 3x times 1x. And then 20. I have quite a few choices for 20. 1 and 20, 2 and 10, 4 and 5, 5 and 4. Okay, so that's it for 20. Not too bad. I have to make 17x in the middle. It's negative 20, which means that I'm going to have one positive and one negative, and the bigger one is going to have to be positive because it adds up to positive 17. So let's try the first, 1 and 20. So I know that 20 minus 3 is 17, so I can probably make this work. So I'm going to put the 20 with the 1 and the 1 with the 3, because then 3x times 1 is 3x, and 1x times 20 is 20x. Now if I want this to make positive 17, I'm going to have to make this a negative, so that is a minus 3x, and this a positive, so that's a positive 20, and then that would make 17 in the middle, and then negative 20 on the end. So then that would be your answer. I got lucky there because I used the first choice. It really comes down to thinking about it, to what combination would work, and then trial and error and guessing and checking and multiplying it back out to see. With this one, it's a little bit trickier because you have two choices for 10. It could either be 5x and 2x, or it could be 10x and 1x. So if it's not prime, it makes it a little trickier. So since it's plus and plus, you do know that both of your factors are going to be positive. And then you just need to think, well, multiplies to 3 at the end. So there's only one choice for the end. It's going to be 1 or 3. So then just try them out. So if I put the 1 here and the 3 here, how does that work? So outside together would give me 15x. Inside would give me 2x. And that's 17x. So the first one I tried works here. If I would have tried it over here, 1 and 3, on the outside I would have got 30x, and on the inside I would have got 1x. Even if I would have reversed this, I would have got 10x and 3x, still wouldn't have made 17. If I would have reversed these, I would have got 5 and 6, which doesn't add up to 17. So it wouldn't have taken me four tries at most to figure out that this was the right one. All right, give it a try. We will practice this again tomorrow. We're going to talk about greatest common factor as well. If this didn't make much sense to you, try the other